looking for
What?
it.
Now your big old face is on it.
No, it's not. You didn't. Okay, you got. Stop it.
Alright, today we're talking about the quadratic formula. Alright, up until this point, we have solved quadratics using algebra, which is where we use the square roots, right? We've solved them by factoring. Okay, now what the quadratic formula does is it gives us another option to solve quadratic equations. Okay, and it also allows us to solve quadratic equations that can't be factored. Okay, because usually factoring is the easiest way for us to solve these. It's pretty quick, pretty easy, and it gives us our answers relatively simple. All right, the quadratic formula allows us to solve quadratics that can't be factored. So, we're going to start by going over what it is. Okay? It starts off with x equals, because x is our solutions. Those are our roots, our zeros. And then we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, it looks really complicated, it looks really scary, but I guarantee you, once we start using it, it's not that bad. Alright? So, if we remember, standard form of a quadratic is like that, right? ax squared plus bx plus c equals 0. That's what we want to get our equations to look like before we can start solving them. Okay, we always want to get everything on one side equal to 0. Once we do that, we know that the number in front of the x squared, the coefficient here, that's a. Coefficient in front of the x term is b, and the constant on the end is c. Okay? Once we know what a, b, and c are, all we have to do is plug them in here, and that's going to give us our solutions. So let's look at an example. If we have x squared plus 6x plus 8. Okay? Now, if we want, we could factor this, right? We could say, well, I have a coefficient of 1 here, so I'm going to put my two parentheses, and I know I'm going to have x and x. Signs are the same. They're both positive. Factors of 8 that add up to 6, 2 and 4. Okay, or 4 and 2. It doesn't really matter the order we put them in here, since we have the almost just fell over. We have the same sign here. See that? Or was I going like this and then it went like that and it almost fell. Now,
Don't worry, we gotta have a camera. So.
Once we do this, we set these equal to 0, and then we solve them. So we have x equals negative 2 and x equals negative 4. Okay? Let's say that we didn't see that we could factor this. Let's say that we just wanted to use the quadratic formula to solve this. So I have this right here. Okay? Now, what I want to do is figure out first what does A equal, what does B equal, and what does C equal. So what's my A value here?
1.
1. What about B?
6.
And C? Okay. Once I have that, I can go ahead and plug these values into the quadratic formula. So, negative b plus or minus the square root of b squared, so 6 squared, minus 4 times a times c, all over 2a. Okay? So the first thing I want to do is just plug in all of my variables right where they belong. The next thing I want to do is go ahead and start simplifying this stuff. Okay, so my -6 is about as simple as I can get. And I have plus or minus. Now inside the square root sign, 6 squared is what?
36.
Okay, 36. I have to do that first because of order of operation. Then I subtract, and what's 4 times 1? Times 8? 32. All over 2 times 1? Just 2. So what I have is -6 plus or minus the square root. What's 36 minus 32? Just 4. All over 2. Okay? Once we get to this point, if you can simplify this square root, if you have a perfect square, you can go ahead and replace that with the number. So now I have -6 plus or minus square root of 4 is 2 all over 2. Okay? Once we get to this point where we have a number plus or minus another number all over a number, or if this isn't a perfect square, if you get to this point where we have a number plus or minus the square root of something all over another number, this is where we split it. Okay, this is where we get our multiple answers, because we have a plus and we have a minus. So we take this and we take this and we say, all right, up here I have -6 plus 2 over 2, and here I have -6 minus 2 over 2. Okay, so once we get to this point where we have number plus or minus a number all over 2, where we simplified everything down as far as we can, we want to split it. And once we split it, one of them gets the plus, one of them gets the minus. Then we go ahead and simplify that. -6 plus 2 is -4 over 2, which is -2. -6 minus 2 is -8 over 2, which is -4. So I get -2 and -4 as my solutions, which I also got when I factored it.
Why don't we do that?
Why don't we do that? You probably would do this. Okay, this is 3 steps. Factor it, rewrite it equal to 0, solve them. Okay, 3 steps, real quick, real easy. This looks pretty long, kind of drawn out, a lot of steps. Okay, it's not really that hard, but there's a lot of steps. And like I said, if you can factor it, factor it. Okay? But the quadratic formula also works when we can't factor it. So let's look at an example of that. So let's say we have x squared minus 10x plus 5. Okay? Now, can we factor this? No. There's no factors of 5 that can go together to make 10, right? But what we can do is we can plug this into the quadratic formula. We can say x equals, what's my a value? 1, b, -10, and c is 5. Okay? So I have x equals negative b, which is -10. So I have -10, plus or minus the square root of b squared, or -10 squared, and you notice it's in parentheses, okay? Because we're taking -10 times -10. Minus 4 times a times c, all over 2a. Okay? Are there any questions at this point? All right. So now I can start simplifying. -10 is +10. Plus or minus. -10 times -10, or -10 squared is what? 100. Minus 4 times 1 times 5? 20. All over 2. Or 10 plus or minus the square root of 80 all over 2. Right? Now, I simplify square root of 80? Okay, is it a perfect square? I guess it's a better question. No, it's not. Okay, if it were 81, then I could change it to not. But square root of 80 is not a perfect square. So, what we want to do, okay, in a situation like this, is we need to split it at that point. Okay? So what I have is I have 10 plus the square root of 80 over 2, and I have 10 minus the square root of 80 over 2. Okay? Now once we do this, we can go ahead and we can approximate an answer. Okay? If you needed an exact answer, then this would probably be where you're at. You might want to reduce this radical down some, but we haven't gotten to that yet. So you aren't sure how to do that. But if we want an exact answer, this would be our exact answer. This and this. Okay? But if we want to approximate something, I can figure out the square root of 80 is about 3.94. Okay? Or we'll call it 3.9. So this is about 10 plus 3.9 over 2. And this is about 10 minus 3.9 over 2. Or 13.9 over 2 and what? 6.1 over 2? About. And if you want to go even, or you can go ahead and say 13.9 divided by 2, 6.95, and 6.1 divided by 2, 3.05. Okay? Those are approximations because the closest we can get to the square root of 80 is a decimal that goes on forever. Alright? We just ended up rounding to the nearest tenth. So that's really close to what the actual solution would be. Now all of the problems in your homework should work out perfect. Okay? There should be situations where the square roots are going to be perfect squares, so you can actually work that out and get a number. Alright? But this is why we have the quadratic formula, Zach, is because there are situations when we can't factor. Okay? Now, if we look at the quadratic formula, and we look at a particular piece, namely that piece right there, the stuff that's underneath the square root sign, the radical sign, okay? What that's called the discriminant. Okay? And it's what's underneath there. So b squared minus 4ac. Now, how many solutions do quadratic equations have? Or how many solutions do quadratic functions have? They could have 2. There's other possibilities here. They could have none or 1. Okay? If it never crosses the x-axis, it doesn't have any solutions. If the vertex is on the x-axis, it has 1 solution. And if it crosses twice, it has 2, right? So it can have 0, 1, or 2 solutions, depending on where that graph's at. Now, the discriminant can tell us how many solutions a quadratic function has. Okay? Because let's look at it. It's underneath the square root sign, right? Can we have the square root of a negative number and have a real number solution? No. Okay? So if the value of this is negative, then that can't happen, right? We can't work this out, and we have no solution. So if the discriminant is less than 0, then there's no solution. Okay? What about if it's equal to 0? What's the square root of 0?
1. 0.
0. Okay? Square root of 0 is 0. So if I have something plus 0 over a number and something minus 0 over a number, I'm going to get the same thing, right? So that means that if the discriminant is equal to 0, then there's only one solution. Okay? And what happens when we get a discriminant that's greater than 0? We get two solutions because we have to add that number and then we have to subtract that number. Okay? So if the discriminant is greater than 0, then we have two solutions. Okay? So the discriminant is what's underneath the radical sign. It doesn't include the square root sign. It's only what's underneath it. So it's b squared minus 4 times a times c. Okay? So to find the discriminant of a quadratic function, all you do is figure out what b is, figure out what a is and c is, and then you say b squared times or minus 4 times a times c. So you just do what's underneath the radical sign. If it's negative or less than 0, then there's no solution. If it equals 0, there's one solution. And if it's greater than 0, then there's two solutions. Okay? Are there any questions about this? Do we want to do another example of using the quadratic formula? No? Anybody have any questions? You think you got this? Okay. Serious, you got it? Mm-hmm. Sure? 100%? All right.
Yeah.
Say hi to everyone.
Hello.
Say hi to your classmates.
I love you.